Standard deviation is a random number that basically, it's like a statistic that tells you how accurate, let's say, a machine is. So I'll give you an example. Imagine a machine's job is to make 50 mil screws. Is that alright? And the machine does this. The machine goes, one machine does 49.8, 49.9, 50, 50.1, I don't know, 50.4, and for argument's sake, 50.6, okay? The machine 2, so that's A, and machine 2 does the following. The machine 2 goes 49.7, 49.9, 50, 50.1, another 50.1, and then for argument's sake we'll go 50.4. And you're asked to go, well, which machine is more accurate? Which machine gives me closer to what I'm looking for? The standard deviation is the method that chooses this, alright? Now, in machine C, and let's say machine C for argument's sake just does this. Can anybody tell me what the standard deviation of machine C would be? No, its mean would be 49.8. What would its standard deviation be? Zero. It doesn't deviate. That would mean that's the perfect machine. Standard deviation would be 0. So, if you're looking for a machine to be accurate, the lower the standard deviation would be the machine you would work with. So, can I have left side of class, you're on group A, right side of class, you're on group B, and here's what we're going to do. So, open up a few more windows, I'd say. Or a door. Alright. Go to mode. Go to stat mode. And we'll just do one variable for the time being. Anybody on the old calculator choose mode? Who's on the old calculator? So mode statistics, is it, Michael?
Yeah.
Mode number 2, is it?
Yeah.
Okay. Now, you put in your numbers, so I'm going to do group B. So I'm going to do 49.7. I'm going to do 49.9. 50. Actually, do you know the funny thing is I can actually I can install the old calculator, I think, into this computer as well. Should do that. Have both calculators handy on me. Okay, we cool with that? Now, I press AC. Now, as the lads told me earlier, C, for the people on the new calculator, COPTN. That gives you, and C, variable calculation. Alright, now I'm going to have to make this a bit, bigger. Okay? For those of you on, the new calculator, press Shift, and is there stat in yellow writing?
Yeah.
What number is it? So choose Shift number 1, and what does it read?
Type data some variable in max.
Type?
Type data some variable over min max.
Variable. Press 4 for variable.
And then it gives n.
Alright. So, the following symbols are the following. X bar means the mean. The mean of my data was 50.03. So if any of you choose X bar, that gives you the mean. Is that okay? Now, everybody will also see something down here called delta X. Or sigma X. Sigma X is my standard deviation. This has a standard deviation of 2.13. Did anybody successfully do the group A calculation?
Yeah.
Could you tell me the mean of group A? Or sorry, just give me the standard deviation of group A.
0.281.
Wasn't much in it. But group B has a more accurate machine. What was the mean of group A? Just go back and go into your data and find it. What? 50.13. Now you can see that you can see that both data sets using bring it up to me in a second if you get a maths error, right? Next thing we're going to do is the following, alright? We're all going to do 7 part 3 together. Okay? Now we're going to do it, we're also going to do it manually, alright? And in the last couple of years of the past exam papers, I've never had to do it manually once, okay? But if they introduce a variable, back when I was doing the Leaving Cert, we used to do these manually, and occasionally they'd throw in letters instead of numbers, and it'd be really, it's a war to do these out, alright? Looking for you guys, they haven't done them like that in a long time. There will be 1 or 2 questions in the book that we will do manually, but I'm just saying they're very rare, and I haven't seen them in the last couple of years, okay? So let's do this. First of all, we'll do the calculator. Everybody enter those 6 numbers into your calculator. Okay? So I'm going for mode, statistics. We'll go for 1 variable. Okay, we'll go for 1, 3, 4, 6, 10, 12. And then we press AC. Then we press I press options for me. I select my calculations, and then because it's so tiny I'll need to enhance it and make it larger for you guys. Alright, now everybody get an average of 6, and most importantly the standard deviation, which is 3.87. Is that cool, you guys? Now here's going to be the fun one now. Ready for this? Alright, how do we do it manually? Okay, step 1, calculate the mean. So add them all up and divide by 6. I'll save you the hassle, we already know the answer is 6, alright? Next thing you're going to do is you're going to get each number and you're going to take away the mean. So the x part represents your number. Does everybody see that? So the first one's 1. And what do you do with the number 1? You take away the mean. So it's going to be 1 minus 6 squared. Okay? The next one's going to be 3 minus 6 squared. What does that epsilon symbol mean? That's why we're adding them all together. It's your number, take away the mean, square it, add them all together. Okay? Alright? And okay? Now, next thing, throw all that into the square root sign. Alright? Now you're not going to do that, you're not going to enter all that directly into your calculator, that'll be a waste of your time, alright? And then divide it by the square root of n. What do you think n is? How many numbers did we have? 6, alright? Now what I'm going to do instead is I'm going to do the square root of, what's that, 25, yeah? Second one is 9, third one 4, fourth one 0, next one 16, and then and then all over all over 6. Is that okay with you guys? Alright, if I throw all that into my calculator, what should my answer be? It should be 3.87. Right, so it has to be 3.87, otherwise it's all gone wrong. So so 34 plus 4 is 38. Lads, stop speaking, lads, you're slowing me down. 38 plus 16, 54. 54 plus 36. What's that, 80? 54 plus 36. 90. Let's do this again. 34, 38, 54, 54 plus 36, 90. 90 divided by 6, square root of 15, otherwise known as 3.873. Same answer, wasn't it? So that's how you manually do it versus doing it by calculators. Everybody cool with that? Alright. So, in class now. Alright lads. Now, so for those of you that are looking at me, there's a little thing for those of you with the new calculator or the master race of calculator. What we can do is this, okay? What we can say is menu, statistics. Everybody see A plus BX? Shh. Alright guys, see A plus BX. Okay? That actually gives me the ability to do both data sets at the same time. I know.
That's crazy.
So, sorry. So you go back. Oh man, I don't think it's letting me go back up though. So there is a catch to that. I think I have to enter in both points. Have to enter both them in at the very beginning. So what do I do? 2. Oh, there we go. 2 and what's the first one? Well, you should be able to scroll up after any equal sign though. Yeah, I can scroll up after any equal sign and change stuff. 13. Alright, I know what to do now. 4, 5, 6. Go back up here. 14, 15, 16. Can anybody make a prediction about the 2 standard deviations? Now lads, I'm going to do exactly what we did last time. Going to press the AC button, going to press options, and you'll see there's extra ones, isn't there? There's something called regression. We haven't got that far yet, don't worry about that. We're just going to use two variable calculations, alright? Now, yeah, looking at this, you're going, what has just happened? Alright? And here's exactly what we're going to do. First of all, we're going to make this a lot larger. Okay. Oh, for God's sake. Alright. Yeah.
What does this mean?
Alright. Chill out. Before I interpret what is on the regression, right? What do you get as what did you get as the standard deviation? What do you get as the standard deviation?
1.41.
1.41. Okay. Did anyone get 1.41 for the second one?
No, it's 1.41 for the second. We were just first the second one.
And what's the first one? Yeah, exactly. Now, you shouldn't be shocked it's the same standard deviation in both of them. Can you tell me why it's the same standard deviation? They're both spaced the same way. It's a gap of 1 between each one, isn't it? So both of them are spaced the same way. So, essentially, it brings out the question, and I need you to understand this and hear this, okay? If I have a score, would you everybody agree that the average of the first one's 4? So, and basically my data tells me everything you have. Look, there it is there. There's my average of 4 for X. There's my standard deviation of 0.1414. If I go over to the Y section, there's my average is 14 for the second one, isn't it? And then my standard deviation is 1.414. I have exactly the same information you guys have. I just have it all in one go. I just have to press the down button to find it. That's all. Okay? So you just got to recognize the symbols you're looking for. Now, here's what else I want to introduce to your mind here, okay? I have a set of data, okay? The average is 4. I add on, 10 to everybody's score. Okay. Now, alright. Next thing, alright? What I'm saying here is that, imagine I have a set of results, and I go to you guys, oh, we made a mistake, increase everybody's marks by 10. What's the effect on the standard deviation if you increase everybody's marks by 10? Stays exactly the same, alright? What happens to the mean though? Exactly, right? They love asking this in an abstract manner. They'll go, hey, you have a set of results. You add 10 onto every result. What's the effect on the standard deviation? That's what they'll ask you. They won't give you something like this. They'll ask you abstractly, right? Now, the next thing I'm going to ask you to do, we're going to expand on this question a bit because I've seen this done before. What happens if you double every result? Actually, scratch that. Instead of adding on 10, what happens if you multiply every result by 10? What do you think the effect on the standard deviation will be? For me, the gaps are getting bigger.
Standard deviation.
Now, can we now do a standard deviation for the new data and see if it relates in any way, shape, and form to the old data? Okay. I actually don't know, so let's go for it. What?
It's just by 10.
Excellent. Okay. So lads, everybody was clear to see that we've increased every gap by 10, haven't we? There used to be a gap of 1, now there's a gap of 10 between each one. So that means that the standard deviation, when we go options, one variable calculation, and we go for, oh wait a second, that's options, one variable. I got a mean of 40, and now the standard deviation is now 14.14. What you know has happened to the standard deviation? It went up tenfold, didn't it? So that's the sort of question I'll ask you. What happens if we add on 10 to everybody's data? What happens if we increase every result by a factor of 10? So that's the difference, alright? So what's the relationship between the two sets of numbers? They have the same standard deviation because they have the same spacing. What's the relationship between their standard deviations? Oh, sorry. First question 1. What's the relationship between the two sets of numbers? Data set B is just an increase of 10 from data set A. What's the result of standard deviations? Standard deviations are the same because the how spaced out they are is still the same. What conclusion can you draw from these results? If it's the same spacing, it's the same standard deviation. Okay? So standard deviation is not affected by increasing every result by the same amount. That's what you're looking for, okay? Alright guys, some of you will be very interested in knowing how to get the frequency on, okay? I believe it's shift setup. Don't think I've done it on this one. Sorry, on the old calculator. Lads, you're going to press shift setup, you're going to go to statistics, and you're going to put your frequency on. What does that mean? Alright, so what does frequency mean?
Oh, I get it. I see.
Relax for a bit. Alright. Now lads, to do this question, the first thing we're going to do is use mid-interval values, okay? 1 to 3 can't be done, so we're going to say, oh, that's 2. 3 to 5 can't be done, that's 4. 6, 8. When you use mid-interval values, it's an estimate. It's not 100% accurate. Does everybody got that? So we can't guarantee the accuracy. It's just a fast way to get a rough estimate of where you're at. Nextly, go to your calculator, go statistic, do one variable, and you'll see the frequency table beside it. This means that I'm claiming that 2 turns up 4 times. So there's 4 2s. Alright? And then this means 3 4s for the next one. Okay? And then, what's it? 9 6s. Okay? And 2 8s. Okay. Everybody cool with that? Now, here's what we're going. Okay? We press AC. Now, before we do this, how many people are in this? You add up the frequency, don't you? So it'd be 7 plus 9, 16. There's 18 people in the class, so to speak. Or 18 people you're interviewing. And some of them are in classes 1 to 3, 3 to 5, 5 to 7, 7 to 9, okay? Or that's the result they got, let's say, okay? So there's 18 people in total, just remember that. Now, we're going to statistic, we're going to go to options, one variable calculation. Oh wait, I keep doing that. Options, one variable calculation, which is button 2. And there's all your data. Lovely. There's all your data. Okay. Lads, how many has got a average of 5? How many has got a standard deviation of 1.9148? Yeah. Is that okay with you guys? Yo.
Agnes said, make sure the mean below 5.
Use mid-interval. No. Use mid-interval values to show that the mean of the group frequency distribution below. What that means is that it just wants you to take. It will just want you to take the data below. Yeah, I know. It won't happen in leaving. And lads, show that the answer is 5. Done and done. Okay. Alright, lads, really quickly. Lads, you looking? Okay. It gives me 4 numbers. You ready? That's the first number, second number, third number, fourth number. The mean of those 4 numbers is x bar. That means x bar is add those 4 numbers together and divide by 4. Okay with that? Okay. 4a plus 8 divided by 4. And then x bar equals a plus 2. Is everybody happy so far? Has anybody got any questions about the first part? Part is essentially here's 4 numbers. Get the mean. Add them together, divide by 4. That's all I did. There's 4 different numbers. That one, that one, that one, and that one. They're the 4 numbers. Add them together, divide by 4, and that's your average. Okay? That's all I've done. Nothing crazy so far. Okay? It says express x bar in terms of a. Done. That's my answer. Now, here's where things get a bit crazy. Alright? Do you remember that standard deviation we did earlier? The manual one. So, we're going to have to do this manually. Okay? And here's what's going to happen. Anybody remember the formula? Sum of your value, take away the mean, square it, divided by the number n. Let's fill this out really quickly. What's n? We know what n is. 4. N is 4. Happy days, okay? Now, what we're going to do next is the following, right? 1 take away what? A plus 2. Square the answer. Next one. 9 take away. Yeah, I used to have to do everyone. No calculator, so I don't feel too bad. Okay, and what about the next one? 3a plus 2, is it? Minus 2. Now you're almost better, 3a minus 2. You almost sort of better to do almost like a table format like we're doing here. Just separate it all out. Don't try and do it all in one big line. Otherwise you're doomed, right? Alright gents, here's what it looks like. That's minus a minus 2, isn't it? So would everybody agree the first one is minus 1 minus a squared. The next one is 9 take away 2 is 7 minus a squared. It's not getting so bad now. The next one is minus 2 squared. And the one after that, what's it, just 2a squared? Oh, 2a minus 4 squared. Okay. Now we're going to have great fun squaring all these out. So I'm going to square them out pretty much in my head. Is that alright? I take it that you can all do them individually and square them out. Okay, you're leaving cert honours. You can take care of each one of them individually. The first answer is a squared plus 2a plus 1. The second answer is a squared, what's it, minus 14a plus 49. The next one's just 4. The one after that is 4a squared minus 16a. Oh God, what else? Plus 16. Okay. I'm not even going to introduce the square root sign yet because I simply don't want to. It's just too clustered. Okay. So how many a squareds do I have? Have 6a squareds. How many a's do I have? 2 take away 14, take away 16. Minus 28a. How many numbers do I have? 49 plus 16. Plus your 4 and plus your 1. Plus 70. Now and only now am I throwing in that square root sign. Because all what I did so far is I've actually only done this part. That's where all the work is. That blue part there, that's where all the work is. Okay? Is everybody cool with that? And then you divide it by 4. And what does the standard deviation equal again?
Root 20.
What?
Root 20.
Just 20, yeah? Root 20. Yeah. Lads, for me I'm squaring both sides. So what do I get then? 6a squared minus 20a plus 70 all over 4 equals 20. 4 times 20? 80. Gets easy after this, doesn't it? And then 70 take away 80. Oh, sorry, 80 take away 70. Minus 10.
Yeah.
Okay, you can divide by 2. Okay, you can all factorize that. It's a equals minus a third, or a equals 5. Reread the question. Does it want 1 or 2 answers? Value. Element Z. Value means one of the answers is not acceptable. Which answer is it? Because no fractions allowed. Right? So, I did the following questions today. Yourselves, you're going to do 9, 10, 12, 14, 15. And yeah, you can't do percentiles yet, so I'll leave that alone.